Hi students, welcome back in lecture number 8 of our course CNC Machining Programming. And in today's lecture, we will do program for drilling cycle by using code G74. The purpose of drilling cycle is to make holes in our workpiece. Let me write this. This is the syntax for our drilling cycle. G74 RE, and the second line G74 X value, Z value, Q value, and then F value. So in G74 cycle, we have two lines. And let me write this, that this is the syntax for our drilling cycle. Now let me explain you this syntax line by line. So as you can see here, in the first line, it is written here G74RE. And RE stands for return amount. Let me explain you this with the help of this workpiece. Let us say on this workpiece, we will perform our drilling operation. And this is the cutting tool. So the movement of the cutting tool will be like this. Now this forward movement is the drilling depth, or the depth of cut, how much we are inserting the tool inside the workpiece, and then how much we are retracting the tool back. Okay, so this movement, retraction, is the RE value here. I hope you're getting it. So RE stands for return amount or retraction. After then, in the second line, we have X value, X always 0. So X stands for diameter, as you know. And if you see this workpiece, at the center of this workpiece, we know we have X0 and Z0. So X we are taking here 0, that on the center of this workpiece, we are doing our drilling operation. So X we are taking here 0 in mm. Then Z is the drill depth, how much depth we are providing in order to make the holes. Then Q is the depth of cut in Z axis in mm or micron, this Q. This is the depth of cut in Z axis. And F stands for feed rate in mm per minute or mm per revolution. The same code in some books you may find in such a way. G74 RE value. Then in the second line, G74 X value, Z value, then P value, Q value, and then F value. This is also correct. Let me explain you what is P here. So P here is the depth of cut in X-axis. Or we can say this is the stepping in X-axis. Q, sometimes we can also define this, that this is the stepping in the Z-axis. So similarly, we can write for P here that this is the stepping in X-axis. And in which situation we will use P? For example, let us say we are doing grooving operation. So in grooving operation, we need to step the tool in the X-axis. Let me explain this with the help of a figure. Let us say this is the figure for our drilling operation. For today's lecture, we are going to write our CNC program for this particular workpiece. And here we are making a drill hole of 24 mm depth with the cutting tool diameter as 6 mm. And the total length of this workpiece is 70 mm. And diameter of this workpiece, let us say it is 25 mm. So this is a cylindrical workpiece. But I was explaining you this P depth of cut in X-axis. So let us say that we are going to do a grooving operation here. This one. Since it is a cylindrical workpiece, so it will be just like this. And in order to make a groove here, we need to take a grooving tool. Let us say this is our grooving tool. You already know at the center of this workpiece, we have our work coordinate system. This is our Z. This is our X. So if we move here, one second. if we move here with respect to this center point, it will be our negative Z movement, and this will be our negative X. So let us say, in order to make this groove here with the help of this grooving tool, we need to step towards X-axis, because since this is our X-axis, so we are stepping in X-axis in order to make this groove here. So in that case, we will use this P value here. Since for making a hole here, we are stepping towards which axis? We are stepping towards Z axis. So that's why we have written here Q value. So if you want to write P value here, that X, Z, P, then P you have to be kept 0. Okay, you can use, there is no problem in that, but kindly remember that P you need to keep here 0. So I hope this is clear to you that while we are doing drilling operation or grooving operation, you can use the same cycle in order to make groove also. So now let us move ahead and try to write our program for this drilling cycle. Now, as we know, this is the starting of our program. O1007 is the program name. You already know G21, G99. These are the initial settings. G21 is the input in mm. All the dimensions which are shown here are in mm. G98 is feed. So G98 is the G code for feed rate in mm per minute. Then we have next block. Then we have M06, the machining code for tool change. T08 is the tool number, and next 08 number is your tool offset. After that, we are rotating the spindle M03 in clockwise direction with RPM 500. Now we are moving the tool from its home position to this particular position, X0 and Z5 with rapid reverse. So G00, X0, Z5 is the location. Let me draw this location for you. Let us say at this particular point, we already know we have X and Z value as 0. So this is our Z, this is our X0 line. Z5, let us say it is 1, here it is 0, 1, 2, 3, 4, or let us say it is 5. So at this particular point, we have our drill bit. So we are calling the cutting tool from its home position. Let us say this is our home position. Okay. So from its home position to this position, we are moving the cutting tool with rapid reverse. So this is the location of X0 and Z5. Let us say. Now after that, we are using our D74 drilling cycle. In the first line, R1. R1 means return amount. So while doing the cutting operation, I'm returning the tool back, or retraction will be 1 mm. Kindly remember this. So after that, in the second line, it is written G74 X0. So X, we are always taking 0 here. It means we are making hole at this particular center point. Z -2, it means the drilling depth we are taking here, -2, that is 2 mm drilling depth we are taking. Q is 0.5. It means that depth of cut in Z axis, we are taking 0.5 every time. Or we can say the stepping in the Z axis, we are taking 0.5 mm. So when drilling operation occurs here, it will be like this, 0.5, it will move ahead or in the forward direction, then it will retract 1 mm back. It will be 0.5, 1 mm, 0.5, 1 mm. I hope it is clear to you. After that, we have feed rate, that is 80 mm per minute. And this particular drilling cycle we are using just for centering purpose. I will explain you this, that why we are doing this. Let me write this. Now, let us say on this cylindrical workpiece, we are going to make our drilling hole with 24 mm drill depth. Now, when the cutting tool approaches the workpiece, and it will touch the center point of this workpiece, that is X0, Z0. Now there are the chances that this cutting tool, when it will come in contact with the workpiece, that it may deflect from the center. Okay, so in order to avoid that particular situation, what we are doing here, we are making a hole of, let us say, 1 mm or 2 mm here at the center of this workpiece, so that when the next cutting tool will come and it will perform the machining operation, it will come in contact with this workpiece and do not deflect. Okay, there will be a already a small hole, or we can say a position for this cutting tool, and it will not deflect from this particular center point. So I hope you are clear that why we are doing this centering. After that, we have G28 use.w0. It means now we are keeping the cutting tool to its home position. Then we have a machining code for tool change. Now we are changing the cutting tool here, and we are calling tool number 4. Initially, we had a tool number 8 here, you can see. Now we are calling tool number 4, and we are now rotating the spindle again with 500 RPM, and we are now keeping the tool at X0 Z5 with rapid traverse. So now the next cutting tool will be at this particular location. And we have this drilling cycle again. Okay. So we are calling G74 cycle and defining all the parameters again. That retraction amount, we are taking 1 mm again here. G74 in the next line, X0. Okay, always we are taking X0. Now we are taking drill depth here, this 24 mm. Then Q is the depth of cut in Z-axis or stepping in the Z-axis. Then this is feed in mm per minute. I hope it is clear to you. So it will make a hole of 24 mm drill depth. And after that, it will return back to its home position. Then we are keeping the spindle off, M05, and then program stop and rewind. So from here to here, this is the ending of the program. This is already written here, starting of the program. And from here to here, this will be our profile program. Now, I hope this drilling cycle is clear to you. In order to understand this better, let me run the same program in a simulator. This is our CNC train simulation system. Now you are already familiar with this. On the left hand side, the same program is written, which I was discussing with you. There are little modifications here, which you can note here, that in the first line of drilling cycle G74 R 1.5. So retraction amount I'm taking here 1.5 instead of 1. Then in the second line of G74 Z -20, I'm taking drill depth as -20 mm. Q is 1000. So this value is in micron here. 1000 means 1 mm depth of cut, or stepping in Z axis we are taking 1 mm, and the retraction of the cutting tool we are taking 1.5. So 1 mm, 1.5, 1 mm, 1.5, just like this. And feed we are taking in mm per minute here. Now let me run this simulation and let us see how it will make hole here. So cutting tool is coming from its home position, and this is the position of X0, and Z we are taking here 2. After that, it will perform our drilling operation. So this was the simulation for this drilling cycle. And in this program, we have not take centering operation. And for that, let me introduce you with the another simulator where we will do the centering operation also. And after that, we will do same drilling operation there. This is one of the simulator in CNC whose name is CNC Simulator Pro. And I'm using trial version of this simulator right now. If you want, you can use this simulator because it is a very good simulator. And let me now make you familiar with the simulator, that how, if you want to use this, how you can use this. On the left hand side, you can see different icons are here: home, zoom window, zoom, and so on. So when we will press the home button, it will be like this. This is our zoom window. It means it will zoom a particular window, which we will grab like this. Then we have zoom. When we will press the zoom icon, it will zoom out and zoom in our machine. Then we have pan. With the pan, we can go left and right, up and down like this. Okay, and this is our rotate icon. We can rotate with the help of this feature. Then we have zoom fit. It will fit the machine with respect to this window that we have. Okay, and we can also, we can also use all these functions with the help of our mouse. If we scroll our middle mouse button, if we scroll this, it will be zoom in and zoom out. And if we press our right mouse button, it will be basically pan on left hand side or up and down. And if we press shift button on the keyboard and middle mouse button, then it will be like zoom in and zoom out. So you can use all these functions with the help of your mouse also. And on the right hand side, you can see this is our controller, the same controller which is shown here. We can control our machine from here, from this controller. This is your X, Y, and Z axis. This is your start. When we are going to start our program or start our machine, we will press this button. We can stop also. We can reset the machine from here. We can shut the door from this button and open the door from here. Okay. Then this is the editor. Here we will write our program. On the right hand side, here we will write our CNC program. After that, we have some more options here. Let us say I'm using open machine. So here we have different kinds of machines like milling machine, different kinds of machine you can see here. Turning machines are there, cutting machine, 3D print. Then we have some miscellaneous machines over here. But we are interested at the turning machine because we are working on this CNC turning programming. And in turning machine, we are taking turning center machine, and you can load that machine also. So when you load, it will come up just like this. After that, you can go in the file option and you can open your CNC program. Okay. So there are three options here in open program: user program, demo program, and machine built-in demo. So these both are for basically for us for demo, that how CNC simulator will work here. And this is the user program. Here you will find the program which we have written here. So let me just load G74 here. So the program which is written here, we have loaded the program. These are the initial settings. That is all the dimensions are in mm. I'm using here. This is lathe machine, and this is the part. I'm basically taking part number 1. So there are 5 parts you can see here: 1, 2, 3, 4, 5, and I'm using part 1. Okay, or you can directly right click on this part 1. Okay, let me show you all these parts. If you go in the settings and open your inventory, here you can see that this is our tool. Okay, tools, different types of tools are here in case of CNC turning machine. There are total 46 tools here. This is T1. T1 stands for tool number 1, left hand roughing tool. Then we have T2, left hand finishing tool. So you can find different types of tools here. After that, we have some milling workpiece that we are not covering here. When we will start our CNC milling programming, there you will see that we have such type of workpiece, like a square workpiece or a rectangular workpiece with some length, width, and thickness. Then we have lathe workpiece. Here we are interested. So the program for which we were writing our program, the cylindrical workpiece, whose diameter was 25 mm and length was 70 mm. So here we are taking length as 100 mm. If you want, you can add new workpiece from here. Okay, let us say I'm adding a new workpiece. I'm taking a diameter of, let us say, 50 mm, and length we are taking 100 mm, let us say. So when doing this, it will load the same workpiece with all these values: 50 mm in diameter and 100 mm in length. You can see here. Okay, and you can give the name also. Let us say this is workpiece number 6. So it will be workpiece number 6. And after that, from here, you can select the materials for your workpiece. Okay, you can choose any color from here. Okay, like all these colors are here. You can choose any color. Let me keep this as this color. And you can select the materials also for your material, like metal, plastic, wood, plain. Let me keep this metal. After that, now, after closing this window, if you go here and check your part, now total there are 6 number of parts here. Okay, So I'm taking part number 1 here, okay, whose diameter is 25 and length is 100 mm. You can simply type 1 here. You can click on this. Okay, it will load that particular part here. Then we have this is the program, okay? This is the program which I have written here. Let me just explain you this G92Z77. So by default, the machine is taking this point as your 0, 0. If you want to check this, you can check from here. This is your 0, 0 point. See, this is your 0, 0 point. But as per our program, we are interested to take which point as 0, 0. If you remember, we want to take this point as our 0, 0. And for taking this point as our 0, 0, we need to specify this. So by using code G92 here, I'll check it here. G92, set 0 offset. Okay, so I'm setting 0 offset of Z at 77. Let me explain you this. If you go here in the help, okay, and you go in online help, okay, so let me show you that why I'm taking Z77 here. Okay, so let us press online help. So after pressing the online help, here we have CNC Simulator Pro user guide. And if you go here in simulation tutorials, let us say I'm going in tutorial 2 of CNC turning machine. This is the full tutorial. You can see here. If you want, you can refer it. Okay, how you can load the workpiece, everything is here. But I'm interested to show you this part. Okay, this particular part. CNC Simulator Pro automatically puts the 0 point at the right plane of the jaw. Okay, so this is the right plane of the jaw. So it is by default putting your 0, 0 at this particular point. And total length I'm taking here 100. Okay, so 0 is here at this particular point. The distance from the plane to the spindle is 23 mm. From here to here it is 23 mm. That means that the right end of our 100 mm long workpiece is at 100 minus 23, that is at 77. So from here to here it is 77. So by default, where is your work coordinate system is at this particular point. But if you want to change your work coordinate system, then you can put G92 code here and you can give the value of Z, that is 77. So this point will be now your 0 point, Z0. So I hope now you are getting clarity that why I'm taking G92 and Z77. So that's why I'm taking Z77 over there. Now let me get back to you to the simulator. Okay, so I hope now it is clear to you. Then we are writing our program. We are basically rotating the spindle in counterclockwise direction with 500 RPM. Okay, and we are taking all these tools. Okay, then the program is same, but here we are only using one line for G74 cycle. Kindly remember this. As per this CNC Simulator Pro, we are using only one line X0 Z. This is for centering purpose Z-2, and this is basically your forward motion of the cutting tool. That is, you are going 0.2 mm ahead, okay, in the forward direction. So let me just run this program for you, then it will make clear. Go to the controller, reset, and then start. Let me just, yeah. See, now the cutting tool has changed and now it is moving in the direction of Z minus 9, minus 10, up to minus 24 it will go. Now, if you want to see, you can check the inside view of this workpiece here. If you see here, you can check the inside view. Now, let me run this program in this way by showing you the inside view. This is the first tool making the centering operation up to 2 mm. You see, then yeah, next drill bit is coming, or next cutting tool is coming in the position. Now it is going in the forward direction. This K1 stands for your depth of cut in Z-axis, or stepping in the Z-axis. Now suppose I'm going to change this K1. Let us change this K. Here I'm taking 1, or here I'm taking 5. Let us say. So now you can see the difference. Let me reset it and start the program. reset and start the program. Only into depth of cut. This is 5 mm depth of cut is taking. See, you can see the difference here. Now, I hope this is clear to you that how we can work on this CNC Simulator Pro. If you want to explore more this CNC Simulator Pro, you can explore it. You can go in the file mode. Okay, you can open the demo programs. There are so many demo programs over here. If you run any one program, let us say I'm running example number 8. So this is saying that save changes to current CNC program. Okay, yes. And then let us run the demo program. Okay, let us run the demo program. Then start. Demo program is now rotate. Now I'm showing you the demo program. See. This is the facing operation. Another tool is coming. It is performing the turning operation. This is the grooving operation. There are more settings here. If you want, you can check the chips removal. You can see the limits. You can see the rapid drivers. There are so many things are over here. If you want, you can check all these. Let me run the same program again for better understanding. If you want, you can close the door. It's up to you. This is the drilling operation. Check here, Z. You can check here, G74X0. Yeah, this is boring operation. So I hope now this is clear to you. And that's all for today's lecture. I hope this lecture is clear to you. And still, if you face any difficulty in this video lecture, you can comment me on the comment box of this video lecture, or you can email me on this email ID, which is given here. So thank you so much. And now let us meet in our next lecture. Thank you so much.